Hello sir, I am Krishnendu Paul from second year ECE Department. Today I will be presenting on topic classification of signals. Let's begin. Today I discuss about 5 different types of signals: deterministic signals and random signals, periodic and aperiodic signals, symmetric and antisymmetric signals, energy and power signals, causal and non-causal signals. There are another types of signals like digital and analog signals, uh, continuous and discrete signals, but today our topic these 5. First, deterministic and random signals. Deterministic signals. Behavior of these signals is predictable with respect to time. There is no uncertainty with respect to its value at any time, and the signals can be expressed mathematically. Means these signals is predictable at any time with respect to time, and there is no uncertainty with respect to its value at any time. Examples: xt is equals to sine 3t, and this is a sinusoidal signals, and we can see the amplitude and time varies signals like this graph, and this is not uncertain and it's predictable, as we can see. And next on, non-deterministics or random signals. Behavior of these signals is random, not predictable with respect to time. There is an uncertainty with respect to its value at any time, and these signals cannot be expressed mathematically. As you can see in this graph, there more uncertain. This graphic is more uncertain than previous, and this is random. The value of these signals at any time is vary with time. That's why these signals is called random signals. And the example is thermal noise generated. Periodic and aperiodic signals. Next, signals. For continuous time signals, a continuous time signals is said to periodic if it satisfies the condition. The condition is xt is equals to xt plus capital T. Here capital T is time period of signals. For example, xt is equals to 3 cos 5t plus pi by 6. As it is sinusoidal signals, it will be periodic. Now, according to this condition, x small t is equals to small t plus capital T, it satisfies when the 5 capital T is equals to multiply of 2 pi. Then capital T is equals to 2 pi k by 5. When k is equals to 1, the t is equals to 2 pi by 5 is called fundamental period. But when this condition is not satisfied, then the signal is said to be aperiodic. For discrete time signals, this condition is x small n is equals to x small n plus capital N. N is integer number. For continuous time signals, we see signals at any time, but for discrete type, n is integer. We see the signals for integer value. For example, we take two example. One is x small n is equals to cos 0.01 pi n, and another is x n is equals to cos 0.01 n. For first example, after solving, we get capital N is equals to 200k, and for fundamental period, k is equals to 1 and n is equals to 200, and n is integer number, so this is satisfied, and this is discrete time periodic signal. But for second case, after solving the equation, we get capital N is equals to 200 pi k. For fundamental period, n is equals to 200 pi. This 200 pi is not an integer number, so this is not a periodic, and this is a aperiodic signal for discrete type signals. Now we can represent a signal by as a summation of two periodic signal, and the signal will be periodic when T1 by T2 means the ratio of T1 T2 is a rational number. What is T1 T2? T1 T2 is time period of two different periodic signals, and the period of these signals is the LCM of two period. Means let's suppose xt is a signals is represented by the summation of two periodic signals, and T1 and T2 is two period of these different two periodic signals. Now xt will be periodic when T1 by T2 means the ratio of T1 T2 is rational number, and the period of this function xt is the LCM of the period. Suppose xt is equals to 5 cos 4 pi t plus 3 sin 8 pi t. Now for this we take 5 cos 4 pi t is equals to x1 t and 3 sin 8 pi t is equals to x2 t. After solving this, we get T1 is equals to 1 by 2 and T2 is equals to 1 by 4 for different periodic signal. Now check T1 by T2 is rational or not. You can see that T1 and T2 is equals to 2, means it's a rational number. So that the function signals xt is equals to means xt is a periodic signals. And what is the period of these signals? Period is LCM of 1 by 2 and 1 by 4. It's 1 by 2. Next signal, even and odd signals or symmetric and antisymmetric signals. Symmetric signals are called even signal and antisymmetric signals are called odd signals. Even signal, it exhibits symmetry with respect to t is equals to 0 and satisfy the condition for continuous time signals xt is equals to x minus of t, and for discrete time signals xn is equals to x minus of n. It's mean this type of signals make a symmetry with respect to t is equals to 0. As we can see in this picture, at t is equals to 0 in positive half and in negative half, this is a symmetry, means a mirrored image. And also for discrete time signals is same. What is the difference in continuous time and discrete time? N is here integer number. We can see 1, 2, 3, 4, and here minus 1, minus 2, 3, 4, dot 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 dot. And what is the odd signals? Odd signals not show any symmetry. And the condition for it for continuous time signals xt is equals to minus x of minus t, and for discrete time my xn is equals to minus x minus n. And this is the example and the graphical representation of this for signals for continuous time and for discrete time or signal. Next one, properties. Before going to the properties of symmetry and antisymmetric or odd and even signals, we need to understand about even part and odd part. What is the even part and odd part of the signals? For continuous type signals, even part is x et is equals to xt plus x minus t by 2, and for odd part x ot is equals to xt minus x minus t by 2. And for discrete time signals, similar, we replace the t with n, where n is the integer number. And now coming to the properties. The properties is for even signals, odd part is 0. What is the even signals, odd signals? Discussed previous in this part. Even signals is xt plus x minus t by 2, and odd part is xt minus x minus t by 2, and for this one similar. For odd signals, even part is 0. Product of two odd signals is even. Product of two even signals is even, and product of even and odd signals is odd. Now take an example and understanding the topic more clear, that xn is equals to 4 minus 4 2 minus 2, and from starting from 4, and we can take 0 previously, and there we thereafter we write this equation, this format. The graphical representation is this. You can see xn and x minus n. Now calculating even part, and this is the arrow is in 4, and the right side is minus 2 1 minus 1. In this left part, minus 2 1 minus 1. This is a mirror part. Yes. And for even part, you can see is always start from 0. So mean odd signals is always start from 0. Next one is energy and power signals. What is energy signal? The signal which has finite energy and zero average power is called energy signals. For energy signals, the equation or the we can how we can write, that is E greater than 0 and less than infinite, and power is 0, which we read previous, that is finite energy and 0 average power. And for continuous time signals, the equation is limit t tends to infinite from minus 2 to t. If we integrate the sum the modulus of xt whole square dt, then we get energy. And for discrete time signals, is equals to summation of xn square from minus infinity to plus infinity, then we get energy for discrete time signals. And what is the power signals? The signals which has finite average power and energy is infinite is called power signals. Means power is greater than 0 and less than infinite, and energy is infinite. Means power is finite and energy is infinite. For continuous time signals, now after going before this, we need to learn about the power and the energy. Power is energy by time, and the time is minus t to t, it's mean 2t. So if we divided this energy equation by 2t, then we get this power equation for power signal. And for discrete time signals, the power equation is limit n tends to infinity 1 by 2n plus 1 summation minus n to plus n x n mod whole. And this is about the energy and power signal. Then causal and non-causal signals. Causal signals, for continuous time, a signal is said to be causal if it's defined for t greater equal to 0, xt is equal to 0 for t less than 0. Means for t greater than 0 and is equals to 0, mean 0, from 0 to greater than 0 it's defined, and for t less than 0 means the left hand part of the signals is 0 according to the equations, and then we call these types of signals is causal signals. And for discrete time signals, xn is equals to 0 for n less than 0. Here means the left part is 0 for these signals. It's mean that this type of signal is not depends on the future part. It's only depend on the present and the past part. For non-causal signals, For non-causal signals, the signals is said to be non-causal if it's defined for t less than 0 or for both t less than 0 and t greater equals to 0. For t less than 0, if xt not equals to 0, then it's called non-causal signal. In this diagram or in this graphical representations, but in this signals, we can see for t less than 0, xt not is equals to 0, and from t less than 0 to t is greater equals to 0, these signals are present, so it's called non-causal signals. Now what is the anti-causal signals? Anti-causal signals only defined for t less than 0, only defined for t less than 0. In the signals we can see for t less than 0, it's not, xt is not 0. Next, non-causal signal for discrete time. A signal is called non-causal signal if it's defined for n less than 0 or for both n less than 0 and n greater is equals to 0. And this is similar to the previous on continuous time, where t is replaced with small n, where n is the integer number, and this is the representation of the signals. We can see today's presentation end, and this is the classification of the signals, and there are 5 different type of signals. Thank you.